Alright, this video will be on solving trigonometry word problems. Pretty much every word problem is going to boil down to one of three formats, at least when you're getting started with these. This is the first type. When the angle of elevation to the sun is 52 degrees, a tree casts a shadow of 25 feet. Find the height of the tree to the nearest foot. So got a little picture here. Essentially all angle of elevation means is this angle with a horizontal line that points up. So in this case, if the tree is casting a shadow here, it's going to be casting it from the sun. So if you draw that out, you get the shadow would be kind of this bottom line here. And what this angle of elevation means is this angle here with the horizontal line and the diagonal line is going to be 52 degrees. In addition to this, we know the shadow of the tree is 25 feet. And then it asks us to solve for the height of the tree. So the height of the tree is just going to be kind of this vertical line right here. And if you notice in doing this, what we end up doing is we get a right triangle. We have the hypotenuse, the shadows, the horizontal line, the height of the vertical line, and we know an angle, and we know a side length. So now using what we learned in the beginning of trigonometry, we could use this angle and this length to figure out this height. In this case, the height is the opposite, and the shadow is going to be the adjacent. So what we're going to want to do is we're going to want to use tangent of 52 is equal to the opposite over the adjacent. So toa. So tangent of 52 is equal to x over 25. And now you just solve for x. Multiply both sides by 25, and you get x equals 25 times tangent of 52. Once we type this into the calculator, we get x is 32. So the first type of problem here is just a problem where it's a basic triangle. It gives us two pieces of information about that triangle. In this case, it gave us an angle and a side length, and it's going to ask for a third. In this case, it asks for the height. So if you see a problem like this, you could just set up a triangle and solve for it using what we did in the last part. The next type of problem puts a triangle and a rectangle together. So what that looks like is here. A surveyor is 100 meters from a monument. The angle of elevation to the top of the monument is 41 degrees, and the survey's instrument is 1.5 meters above the ground. Find the height of the monument to the nearest tenth. If you don't know what a surveyor is, you might have seen them around at times on the sidewalk. It's pretty much this tool right here that could measure distance and angles really well, and they use it to figure out the height of objects or the distance or other things related to kind of engineering, architecture, and things like that. So in this case, I put the surveyor right here. And what it's saying is the angle of elevation to the top of the monument is 41 degrees. So in this case, that angle of elevation, it's not going to be from the ground. It's going to be from wherever the surveyor's instrument is. So if you draw this horizontal line here and you draw a line to the top of the monument, your angle of elevation, which is 41 degrees, is actually going to be above the ground. It's going to be from the top of the instrument. And then we also know the surveyor is 100 meters from the monument. So this horizontal line here is going to be 100 feet. So now using trigonometry, we could figure out the height here from the top of the surveyor to the top of the monument. And we just do this using tangent because x is the opposite and 100 is the adjacent. So with that, we could say tangent of 41 is equal to x over 100. And then we multiply the 100 over and we get x equals 100 times tangent of 41. Then we type this into the calculator and we get x is 86.9. Now, in the first type of problem, we'd be done right here. We would figure out the height and we'd move on. But this also tells us the surveyor's instrument is 1.5 meters above the ground. So that means this horizontal line here that I drew isn't going to be on the ground. It's going to be 1.5 meters above the ground. Meaning 86.9 is not our final answer because we need to add this bottom 1.5 to it. So when we add that 1.5 and 86.9, we get 88.4, and that's going to be our height of the monument. So this is the second type of trig word problem you can see where you have a rectangle, and on top of it or below it or somewhere with it, you have a right triangle. So it's not too much more work, it's just this extra step of adding that 1.5 at the end of it. And the last type of word problem we're going to see is probably the toughest, and this is just putting two triangles together. So in this case, Greg is standing on a dock looking at a ship 50 feet away. The angle of elevation to the top of a sailor's head is 24 degrees, and the angle of depression to a point where the water comes up on the ship is 32 degrees. How far is the top of the sailor's head from the water? round to the nearest tenth. So I put a little picture here. In this case, we have Greg here standing on the dock. He's not at the sea level, he's a little bit above the water. And then you have the sailor here who's higher than Greg and some distance above the water that we want to know. So in this case, because it gives us an angle of elevation and an angle of depression, there's going to be two triangles involved here. The angle of elevation goes with the horizontal line and goes up, meaning this top angle here is going to be 24 degrees. The angle of depression is 32 degrees, and that's a horizontal line, and it goes down. So in this case, this bottom triangle is going to have an angle of 32 degrees. The only other information we're given is that the ship is 50 feet away, so that means the horizontal line is going to be 50 feet. Now all we have to do is solve two different triangles. This top triangle here, using the 24 and the 50, is going to give us this top height here. And this bottom triangle here, using the 32 and also the 50, is going to give us this bottom height here. So one gives us the distance from the water to where Greg is on the dock, and one gives us the distance from where Greg is on the dock up to the sailor's head. So we could find these two heights, add them together, and that will give us the total height. So using the similar math to the first two problems, this top height here, x, is just going to be 50 times tangent of 24. And I skipped a couple steps to get here, but feel free to try it on your own. It's just like the other triangles we did in this video. And if we type that into a calculator, we get the top height is 22.3. The bottom one, using a similar thing, is going to be 50 times tangent of 32. We type that into a calculator and we get it's going to be 31.2. Now we could add the two heights together and get our total height is 53.5. So that's pretty much all there is to it. A lot of this is just getting used to the wording. You get a lot of degrees, angles, and distances. It could be a little overwhelming, but it's always going to be one of three main shapes. It's either going to be two triangles, a triangle and a rectangle, or just a triangle. So it's about getting used to the word problem and kind of recognize what words or what information is going to lead to what shape.